The last words humanity leaves behind might not be for our descendants, but for the universe itself. They won't be carved on stone tablets or printed in books. Instead, they are sealed on a golden record, flying towards the stars aboard a space probe. It's the well-known Voyager. And now, we're about to lose contact with it. Its power is fading. Communications are breaking down. This lonely spacecraft may become the only human artifact still moving forward, a kind of last will and testament. So, before it falls completely silent, I want to do one thing: retell its entire story, tell it completely. Because this is more than just a space legend. It's a love letter to the cosmos, from an entire era. It's also our final whisper, left deep within the sea of stars. Actually, it almost didn't even get the chance to launch. In the early 1970s, NASA scientists suddenly realized the universe was quietly handing them a one-time ticket. The four giant planets, Jupiter, Saturn, Uranus, and Neptune, were about to align in an extremely rare formation. If a probe was launched within those few years, it could use their gravity to slingshot from one to the next, completing a cosmic jump across all four planets. This kind of opportunity only comes around every 176 years. Miss it, and you might never get another chance in your lifetime. But a huge problem stood in the way. It was too expensive. Asking for billions of dollars to fund a mission that would fly for decades with no guarantee of success? Congress immediately shot it down. So, NASA was forced to scale down the grand tour to just Jupiter and Saturn, with a 5-year time limit. But in the engineers' eyes, this was just the surface of the mission. The real ambition was hidden in the details. They put extra fuel on the probes, added backup systems, and quietly designed a power-saving survival mode. The moment NASA changed its mind, they could immediately set off to fly even further. This wasn't part of the official plan, but a backdoor the engineers built in advance. An interface reserved for the dream. On August 20th, 1977, Voyager 2 launched first. On September 5th, Voyager 1 followed. Though it had a smaller number, Voyager 1 was faster, overtaking its sibling a few months later. From then on, it was a clear leader. And so, they embarked on a journey no one could guarantee. The first challenge was crossing the asteroid belt. It wasn't as empty as the public might think. It's filled with countless high-velocity rocks and debris. Many scientists at the time bet they would likely be shattered halfway through. But Voyager sailed through safely, without a scratch. It was at that moment its true mission had just begun. The first to welcome it was Jupiter. Voyager 1 arrived at Jupiter in March 1979. No one anticipated that it would completely rewrite our understanding of this gas giant. We had some blurry ground-based images and early data from Pioneer, but Voyager wasn't just observing. It was a close-up encounter. First, the atmosphere. We expected to see rotating cloud bands, but Voyager revealed a much more chaotic, dynamic system. Massive storms, hundreds of miles per hour jets, and layered, alien-looking cloud structures, like a strange layer cake. The most stunning discovery was the Great Red Spot. It wasn't just some red speck. It was a superstorm over 20,000 kilometers in diameter, large enough to swallow 3 Earths. And it has been raging for over 300 years. Voyager's close-up shots confirmed years of speculation. It is a real, planet-sized hurricane system, with winds far exceeding any storm on Earth. Even more surprising were Jupiter's moons. Previously, everyone assumed these satellites should be like our moon, cold, dead bodies. Until Voyager photographed Io. This moon wasn't just an old, cratered rock. It was the most volcanically active body in the solar system. Giant volcanoes constantly erupted, with lava plumes shooting hundreds of kilometers off the surface and into space, like geysers. Some of these eruptions were even captured live by Voyager. The surface was covered in colorful sulfur deposits and solidified lava, like an alien fireworks show. Europa also completely stunned scientists. Its smooth surface was covered in intersecting dark cracks, which initially looked like ice fractures. But people later realized that beneath the cracks could lie an entire global ocean, with a total water volume potentially greater than all of Earth's oceans combined. If liquid water truly exists there, then life might be possible. Voyager changed the way we asked questions. We were no longer just trying to know what these planets are made of, but instead began to ask, could there be life there? Even Jupiter's planetary rings. Voyager was the first to confirm their existence. These rings weren't as bright as Saturn's. They were faint and narrow, composed of dust, only visible when illuminated by sunlight at specific angles. After leaving Jupiter, Voyager 1 and 2 continued to the next stop, Saturn, a planet that in human culture symbolizes mystery and order. If Jupiter represented power and chaos, then Saturn was its opposite, elegant, quiet, and almost surreal in its mystery. But Voyager soon revealed that beneath Saturn's tranquil exterior lay just as many wonders as Jupiter. The most familiar sight, of course, is its rings. Before Voyager, we already knew Saturn had rings, but we had only a fragmented understanding of what they truly looked like. Until Voyager took that stunning series of close-up images. The bands of light that seemed singular were actually structures made up of thousands of tiny ringlets. Incredible. Some rings were braided like thread. Some showed bizarre kinks and even crossing patterns. There were even black, shadow-like structures floating above the rings like ghosts. These are the famous spoke structures. Their existence was completely unexpected by scientists because, according to previous models, such structures simply shouldn't form. One theory suggests they might be dust particles charged electrically, briefly suspended in the air by Saturn's magnetic field. But even today, no one can fully explain their presence, as if Saturn intentionally left a riddle to remind us not to be too confident. However, Saturn's biggest surprise wasn't in its rings, but on its moons, especially the largest, most massive, and most hazy moon, Titan. Before Voyager, we only knew Titan had an atmosphere, which is very rare for a moon in the solar system. But as Voyager approached, scientists realized Titan's atmosphere wasn't just there. It was incredibly dense. The main component is nitrogen, with a concentration even higher than Mars, and close to Earth's. The problem was that Voyager couldn't see through this thick, orange-colored haze to see the true appearance of the surface. However, the data feedback from the instruments pointed to a stunning possibility. Beneath this dense atmosphere, there might be lakes and rivers made of methane and ethane, and even a weather system similar to rain. Except here, it doesn't rain water, but liquid hydrocarbons. Imagine a world with lakes and a weather system, but its rain is highly flammable. Another moon that Voyager nearly overlooked, Enceladus, was confirmed decades later as one of the most likely places for life in the solar system. Voyager photographed certain excessively smooth areas on its surface, which scientists found unusual. Because in space, the older a surface is, the more cratered it should be. Yet some regions of Enceladus were almost spotless. This meant the moon's surface might be undergoing geological renewal. The later Cassini mission confirmed this. Beneath Enceladus's ice shell really was a global ocean, and it continuously spewed water vapor and ice particles, forming plume-like structures, like cosmic geysers. Although Voyager didn't directly photograph these cosmic eruptions, it had already captured the crucial clues. This also made humanity realize for the first time that frozen worlds might have more potential for life than imagined. Additionally, Voyager also discovered several new, small moons, such as Prometheus and Pandora. They orbit near the thin F-ring, acting like cosmic shepherd dogs, using gravity to maintain the ring's edges. These tiny yet precise gravitational interactions are like a perfect piece of music orbiting Saturn. And after completing the flyby of Saturn, Voyager 2 continued flying to even greater distances, targeting Uranus. At the time, this planet in telescopes was just a blurry blue-green speck. No probe had ever approached it. Voyager 2 is the first spacecraft in human history, and currently the only one, to have ever visited Uranus. What it saw completely shattered our conventional image of a planet. The most shocking thing was Uranus's orientation. Its axis of rotation is nearly horizontal. The entire planet is tilted on its side, rolling along its orbit. It doesn't rotate like Earth. It rolls like a bowling ball on the floor. This means its polar regions, rather than its equator, alternately face the sun, with each season lasting 21 years. Voyager arrived at Uranus in 1986. Scientists expected it to have rich atmospheric features like Jupiter or Saturn. But Uranus looked exceptionally calm. The entire planet looked like a polished blue-green glass ball, with almost no cloud bands or storms. However, the instruments found that deep inside Uranus's atmosphere, there were winds reaching up to 900 kilometers per hour. Beneath that tranquil surface exterior was a violently churning gas giant. And its magnetic field was even more baffling. It was expected to be like Earth's, with the magnetic field roughly aligned with the rotation axis. But Voyager discovered that Uranus's magnetic field center was not at the planet's center, and its tilt angle was even greater than the rotation axis. It presented a state of extreme offset and distortion. This bizarre magnetic field wobbled constantly as the planet rotated, forming a chaotic magnetic cannon structure we had never seen before. Voyager 2 also discovered 11 previously unknown moons. The most unforgettable of them was Miranda. It looked like a cosmic jigsaw puzzle, fractured and reassembled, a broken piece. Its surface was covered in enormous faults, deep valleys, and V-shaped ridges. Some cliffs reached heights of 20 kilometers, the highest known cliffs in the solar system. This moon was like the cosmic version of Frankenstein. It looks almost impossible, yet it's real. Furthermore, Voyager also confirmed for the first time that Uranus possesses a planetary ring system. These rings are not as bright as Saturn's. They are dark, narrow, composed of fine dust and small fragments, with sharp edges and a compact structure. These precisely ordered edges are likely formed by the stabilizing gravity of shepherd moons hidden within the rings. The result is that Voyager 2 brought back all these images and data, allowing us for the first time to truly understand this sideways tilting planet. It seems silent, but is full of mysteries. After leaving Uranus, Voyager 2 continued its flight to its last stop, Neptune. This is the most distant planet in the solar system. Before Voyager arrived, we knew almost nothing about it. In telescopes, it was just a blurry blue dot in the night sky. We only knew its size, color, and orbit, but no details. Voyager 2 is the first, and so far the only spacecraft to have approached Neptune. In August 1989, it flew past this distant blue giant, over 4.3 billion kilometers from Earth. The first glimpse amazed everyone. Neptune's color was deeper and brighter than Uranus, a vivid, rich, deep blue. It was also due to methane in the atmosphere absorbing red light, but the effect was more intense and colder. Most surprisingly, it was not tranquil like Uranus. Voyager discovered that Neptune's atmosphere was full of violent storm activity. It photographed rolling clouds, fast-moving cyclones, and an unprecedented giant storm, the Great Dark Spot. This was a storm almost the size of Earth, with wind speeds reaching up to 2,100 kilometers per hour, the fastest known wind speed in the entire solar system. A planet at the furthest reach of the sun, in extreme cold, actually had such violent winds. Scientists had previously assumed that places so far from the sun would have thin atmospheres and low energy. But Voyager's discovery completely overturned this assumption. Neptune's atmosphere was much more active than imagined, with powerful jet streams, polar storms, and rapidly spinning cloud systems, making it a true blue tempest planet. Even more surprising, Neptune also has planetary rings. These rings are not bright. They are made of dark dust and appear incomplete and fragmented in structure. Some segments of the rings were not closed circles, but arcs, with only parts of the ring segments visibly bright. This is a very strange physical phenomenon, because theoretically, gravity should distribute the ring material evenly into a complete circle. But these arcs seem to be held in place by some kind of force. Voyager's data suggested this was likely due to small moons hidden within the rings, using their gravity to maintain these dust arcs. They act like traffic cops in space, making these particles stop where they should. Then, Voyager approached Neptune's largest moon, Triton. It is an extremely unique moon. First, its orbit is retrograde, meaning it revolves backward around Neptune. This suggests it might not be a native Neptunian moon, but a captured Kuiper Belt object. But what was truly stunning was its surface activity. Voyager photographed eruptions coming from its ice sheet. Triton was erupting liquid nitrogen and dark dust, forming geysers up to 8 kilometers high. This was the first time humanity had seen active geysers on a celestial body other than Earth. Its surface was covered in fractures, ice plains, and a bizarre cantaloupe terrain, full of circular depressions and complex textures, like the skin of a squashed fruit. Despite the extremely low temperatures, Triton still showed signs of geological activity. This suggests it might still have an energy source within, or once possessed an internal heat source. After flying past Neptune, Voyager deliberately turned back to take one final photo. It was a blurry blue silhouette, fading away, sinking into the darkness of space. That moment marked the official end of Voyager's planetary mission. It had completed visits to all 4 gas giants, taken countless photos, discovered dozens of new moons, and revealed the deepest secrets of the solar system. But this was not its final destination. It was about to sail into that vaster unknown realm, interstellar space beyond the solar system. Many people think that once you cross Neptune, you are in interstellar space. But in reality, the solar system has a much larger, invisible boundary. It is not determined by the planets, but is an extension of the sun's power. The sun not only emits light and heat, but also continuously blows out charged particles, forming an invisible wind. This is the solar wind. This wind blows a giant bubble, enveloping the entire solar system. This bubble is called the heliosphere. Inside this bubble, the sun's magnetic field and particles dominate. Outside the bubble is the domain of the galaxy, filled with cosmic rays from other stars, particles and magnetic forces. What Voyager had to do was cross the edge of this bubble. The first barrier is the termination shock, the region where the solar wind begins to slow down. As it expands outward and encounters counterpressure from interstellar space, it suddenly decelerates, going from supersonic to subsonic speed. Voyager 1 crossed the termination shock in 2004, at a position about 94 astronomical units from the Sun. Voyager 2 also crossed in 2007, at a position of about 84 astronomical units. But scientists were surprised to find that this region was much more complex than imagined. It was not a peaceful boundary, but filled with turbulent magnetic fields and anomalous particle flows. Next, they entered the heliosheath. This is a more chaotic transition zone. The solar wind continues to slow down, beginning to be churned and compressed by the interstellar medium. Voyager discovered unexpected phenomena, such as giant magnetic bubbles. These magnetic bubbles are twisted structures formed by the sun's magnetic field, potentially tens of millions of kilometers wide, floating like cosmic foam. They can trap high-energy particles, forcing scientists to rethink how the sun and the galaxy interact at the boundary. The true boundary is called the Heliopause. This is where the solar wind completely ends and the interstellar medium begins to dominate. On August 25, 2012, Voyager 1 successfully crossed the Heliopause, becoming the first spacecraft in human history to enter interstellar space. At the time, it was 121 astronomical units from the Sun, which is 18.1 billion kilometers. How do we know it really crossed the boundary? Because its instruments detected a sudden, drastic drop in particles from the solar system, while high-energy cosmic rays from the Milky Way sharply increased. The Sun's magnetic field no longer dominated. Everything had changed. In 2018, Voyager 2 also crossed the same boundary, at a position of about 119 astronomical units. Although they flew in different directions, their crossing points were similar. This suggests that the heliopause is not a perfect sphere, but is squeezed and deformed by interstellar pressure, like a flattened bubble. Now, both Voyager probes are truly interstellar spacecraft. Although they have traveled billions of kilometers from Earth, they are still communicating with Earth using faint signals. These signals travel across space, taking over 20 hours to reach us. What we use to receive them is NASA's Deep Space Network, those large radio telescopes distributed globally. What they receive is not a clear conversation, but a whisper fainter than the cosmic background noise. These whispers are still telling us about the world beyond the solar system. And this communication is no longer just a technological triumph. It's also a spiritual symbol. The Voyager journey is no longer just a scientific mission, but an extension of humanity's instinct to explore. Even as power continues to decay, even if the next data sent might be the last, they are still diligently working. They are using their last bits of electricity to send human curiosity among the stars. Sending a probe billions of kilometers away is itself an extraordinary achievement, but the real challenge is maintaining contact with it. Voyager 1 is now over 23 billion kilometers from Earth. The signal it sends is now fainter than the cosmic background noise. At this point, we rely on NASA's Deep Space Network, those enormous antenna systems, to barely receive these whispers returned from the distant frontier. And along this faint communication line, Voyager has experienced one close call after another. In 2012, Voyager 1 began to transmit a set of anomalous data. The data looked strange, as if the probe had completely lost its bearings. Its attitude data showed it was pointed at positions that were physically impossible. But at the same time, the signal was still clear, meaning its antenna was still accurately aimed at Earth. It was like receiving a letter from a friend saying they were lost in the desert, but the address on the envelope clearly showed they were home. NASA engineers were completely bewildered. They spent months troubleshooting, sending signals back and forth, each round trip taking 22 hours. Eventually, they found that Voyager 1 had somehow switched to a backup computer that had been abandoned decades ago to process attitude data. Why did it suddenly reactivate an already retired system? No one knows. They could only attempt to send a remote command to make it switch back. It worked. Voyager woke up again and returned to normal. But this also reminded us once more how fragile this connection actually is. Voyager 2 also experienced a similar scare. In 2023, a routine command error caused its antenna to point 2 degrees away from Earth. Just 2 degrees caused it to completely lose contact. For several weeks, NASA received no response. The mission team was almost in despair during that time. They could only desperately try to send an ultra-powerful signal from the ground station in Australia, praying that Voyager 2 could still receive it. 37 hours later, it responded. It received the call and re-aimed itself at Earth. The crisis was averted, but only temporarily. Besides communication risks, power depletion is the most critical issue. The Voyager probes use radioisotope thermoelectric generators, RTGs. As the plutonium material decays yearly, their power output is gradually decreasing. To maintain the most basic communication and navigation functions, NASA has had to make difficult trade-offs, gradually turning off scientific instruments and heaters, preserving the most critical life support systems. Some instruments, after losing their heaters, stubbornly continue to operate in the sub-zero environment, far exceeding their design limits. Another hidden enemy is cosmic radiation. In interstellar space, Voyager is exposed to high-energy particle bombardment. These particles can flip bits in the memory, causing program disorder and system errors. NASA engineers must constantly monitor, sending repair commands immediately upon detecting an anomaly. But this process comes with no guarantee, because every command sent and response received requires waiting an entire day. These challenges have not ended Voyager's mission. Instead, they have repeatedly proven its resilience. Both probes have long exceeded their lifespan limits. Their tenacity is not just an engineering miracle, but a reflection of belief. But all journeys eventually end. One day, NASA will send a command, and there will be no reply. Until that moment arrives, they will continue to send back echoes from deep space, letting us know that in the farthest reaches, a voice is still telling the story of who we are. Although the Voyager probes were initially meant to explore the outer planets, the mission they bear is actually far more than scientific. Each of them carries something of profound significance. A golden record. This is no ordinary record, but a self-introduction written to the cosmos, a message humanity sent to any extraterrestrial civilization. Its name is the Voyager Golden Record. This record was primarily designed by NASA scientist Carl Sagan's team. They believed that since Voyager would eventually fly out of the solar system to become truly interstellar travelers, it might be picked up by another civilization in the distant future. If that was the case, why not let it carry a letter, a self-introduction about who we are and where we come from? The record is 12 inches in diameter, made of gold-plated copper. It was designed to survive billions of years in space, immune to radiation, unharmed by dust, and resistant to weathering or corrosion. Its content includes sounds, images, and music, all meticulously selected to represent the diversity of life and civilization on Earth. It is like Earth's business card sent to the universe, a time capsule traveling across time. The sound section includes natural sounds such as thunder, wind, ocean waves, and bird calls. It also includes human sounds, such as footsteps, laughter, heartbeats, and even the sound of a kiss. It reminds us that human existence is not just about technology and development, but also those small, tender, and moving moments. The music section has 90 minutes of content, with tracks spanning different cultures and eras, from Bach and Beethoven to traditional music from Senegal, Japan, and Australia, and even includes a rock and roll song, Chuck Berry's Johnny B. Good. When someone questioned whether this rock song was too modern, Carl Sagan replied, "There are many teenagers on Earth." The record also includes 115 images, encoded as analog signals on the record. These images show human appearances, various animals, plants, cityscapes, and scientific diagrams, such as the structure of DNA, the location of the solar system, and how to locate Earth using pulsars. It is like a cosmic photo album, telling our story through pictures. In addition to this, there are greetings in 55 languages, from ancient languages thousands of years old to modern English, Chinese, Arabic, and Hindi. Each one says something similar. Hello, may you be safe. We are thinking of you. Kurt Waldheim, the UN Secretary General at the time, also recorded a message expressing humanity's vision of connecting with the universe. And the most moving piece of content is hidden within a set of brainwaves. Those are the brainwave recordings of Carl Sagan's wife, Anne Druyan. While meditating, she contemplated the fate of humanity and recalled the moment she fell in love with Carl Sagan. That segment of brainwaves became a code of emotion traveling across the stars, floating in the galaxy. So, the question is, if one day an extraterrestrial civilization discovers this record, how will they play it? NASA very thoughtfully etched an instruction manual on the record's cover. The instructions use universal physical constants instead of written language, such as particle decay and graphical symbols. They even show how to play the record using the included stylus. Even if they don't understand Earth languages, they can understand this information through mathematics and physics. The significance of the Voyager Golden Record is not just to tell others who we are, but also to tell our future selves how we once viewed humanity and how we hoped to be remembered. It is an expectation of peace, a longing for connection,